Hello, my name is Liz Schlemer, and I'm teaching a class in IME 443, Facilities Planning and Design at Cal Poly San Luis Obispo. This particular video is about defining relationships. As we've been talking about, as we've gone through these videos, we're going to be talking about excellent engineering practices, which include quantitative and process kinds of things. And all of this engineering has to be done within the context. And the context is the project or the company in which you're working. So the processes associated with facilities planning are laid out here. And again, we're looking in the area of layout design. We're using this systematic methodology, and the step we're addressing right now is determining interrelationships between the specified departments. So we're going to talk in this video about three aspects of flow, and then also some other aspects associated with how do you define relationships. So we're going to look at flow patterns, flow planning, and measuring flow. So when we look at the patterns in a flow situation, what we're going to be concerned about is sort of three levels of that. The flow within the workstation, the flow within departments, and the flow between departments. So within the workstation, the thing we're most concerned about is methods and ergonomic issues. So making sure there's a sequence of activities and that things are within reach when you're designing a workstation. And these are all aspects of items you've learned in previous courses. Flow within departments. So a department, again, is a group of workstations. So we need to think, well, are there things flowing within the department from one workstation to the next? And this often happens in a product-oriented department. So we might have an end-to-end flow where items flow this way from left to right or right to left, that just one to another workstation. We might have back-to-back, so the people are working, but the flow is going between them. This might happen with a conveyor belt or something. There might be an odd angle flow, and this happens sometimes, especially if there's some structure associated with the building that you need to work around. So you might be having an odd angle flow in a department. And you can see this takes up quite a bit different amount of space than this. So you need to be concerned about how the flow is happening. And then a circular flow is also another way. We've seen this in cell manufacturing, where we have the flow flowing throughout it, which again, it takes up a different amount of space than in a line-to-line flow. There could be front-to-front flow, so somebody could be working on one station, turn around and work on another station. That could happen. Always we need to be concerned about the aisle locations, and especially in this situation, how are things coming in to the workstation and leaving the workstation, and how is the person entering and leaving the workstation. So when we look at flow between departments, okay, so we're going one step up from there. We have all the departments laid out within the building. We need to look at how are they flowing. So a common way is looking at where the shipping and receiving locations are. Oftentimes they're located at the same place. Shipping and receiving occur in the same approximate location. If that's true, then you need to sort of have a circular kind of flow where it begins and ends in the same place. This is an example of an S flow, so it's sort of snaking its way through the particular facility. This is where shipping and receiving locations are at opposite ends of the building. Actually, for visual management and lean manufacturing, this is an ideal way of laying out a facility. The reason is that if you're in the middle of the facility, you know absolutely that how far along the products are. No matter what line you're on, you know they're approximately 50% done. And this is very good for visual management. This is another example of shipping and receiving in our different locations. In this case, everything's sort of flowing to the right and up. So whenever we're doing looking at the flow within departments, we need to make sure that we sort of start at the bottom of this pyramid, that you have effective flow within the workstation, so good ergonomics, good methods that you're using, and then effective flow within the departments so that it's clear how things are flowing within the department from workstation to workstation or from a central storage area to the workstation, however the flow is happening within the department. and then higher than that, the effective flow between departments. Now, this is the one on the right here is a real example of a company in San Luis Obispo that we did an analysis for, and the numbers indicate the particular flow of a part through this facility from building to building, and you can see it's very inefficient. One of the two things that you need to be thinking about when you're developing flow between departments is that there should be an uninterrupted path from origination to destination. So it should be pretty close, that there should be a path that you follow and it doesn't backtrack on itself. The other is that there shouldn't be any intersecting flow lines. And this would just cause actually truly collisions or issues associated with products delaying because they're crossing paths of other products. So then now that we sort of understand flow, how is it that we measure the flow? There's both quantitative ways of measuring and qualitative. In the area of quantitative, we can measure things like pieces per hour, moves per hour, pounds per week, and we can create what's called a to-from chart. So on each row and each column are the set of departments, so storage, QC, manufacturing, inventory, shipping, and receiving. And what you've done is you've measured, say, moves per hour or moves per day between these particular departments. So in the first row, you'll be looking at the move from the storage to quality control is 12 times a day. And then from storage to manufacturing is 3 times a day. And from storage to shipping and receiving is 9 times a day. Now on the other side, if you go from storage to shipping and receiving, it's 8 times a day. So this particular to-from chart is directional. It's not just the times between that. But we don't care at this particular moment when we're looking at strength of relationships between department, which way it's going, if it's going from storage to shipping and receiving or from shipping and receiving to storage. So we create a to-from chart, becomes then a relationship chart. So in the case of the storage and shipping and receiving, we can see we took 12 and 8, we took 9 and 8 and we added it together. And it should be 17, but it's 19. So we add those together in order to get the strength of the relationship. So the strongest relationship is between manufacturing and shipping and receiving at 35. So when we then look at what we then can do is more qualitatively look at, do we have the right relationships? We have sort of a quantitative, but do we have relationships in a qualitative sense? And this we would gather through interviews and surveys. We would look at the organization chart. We could even look at observations. And then we actually developed this AEIOU-X kinds of orientation that indicates how important it is for various departments to be next to each other. So when we're looking at the qualitative aspects of it, we want to look at organizational relationships. What is the span of control? Who reports to who in a situation? Who's in the same department in a particular organization? We also want to look at flow relationships, which we've talked about, flow of material, but also equipment and people and information and money. So there could be a way that information is very, very often exchanged between two people, 2 workstations, or 2 departments, and they should be close together. Control relationships. So is there any material inventory control? Like where do you get raw materials from? Is it centralized or decentralized? Shop floor control. Who is indicating what needs to be done at one particular time, the schedule for the day. There's automation and integration that might need to be together in the same place and have the same control issues. There's often also environmental relationships. Temperature, safety, noise, fumes, humidity, things that need to be together. And this is common in, say, a clean room, that you don't want to have multiple clean rooms. You probably just want to have one clean room. And in addition to things like fumes, you need to make sure that these are near a wall, that they can be isolated or the fumes can be extracted. Any other issues like floor loading, like is there something very heavy, some heavy piece of machinery that needs to be in a certain place, water treatment associated with plumbing, chemical processes, or any kind of special services that maybe needs to be near a door. So all of these things need to be considered when you're developing a relationship chart. So this is an example of a relationship chart. So not only does it have AEIOU in the relationships between these departments, but it also indicates why that relationship is strong. And the coding down below indicates why that particular thing is important. So that kind of is an overview of flow and why it's important that actually relates to departmental relationships. When you've done this well, you will be able to create a relationship chart like this.